So in this question here, we've got a situation where we've got a pulley system and two weights at either end. We've got at the top here, we've got weight A, which weighs 2.5 kilograms, and it's got a resistance force altogether of 12.7 newtons. Now here at point B, we've got a mass of 1.5 kilos, which is 1 metre off the ground. Now we want to calculate these four things. We want to calculate the acceleration of the system as B falls to the ground. The tension, that's the tension in the ropes here, which both sides point towards the pulleys system there. And the time taken for B to fall and hit the ground, and the velocity of B when it impacts the ground. So first of all, let's start with our forces, and let's resolve our forces at A and at B. So first of all, let's have a look at A. So here, as this is moving, it's a moving system, I'm going to use force equals mass times acceleration. So what's the forces at point A? Well, we've got the tension going in the direction of travel, and we've got the 12.7 Newton resistance force going against the direction of travel. So our setup here would be tension minus the 12.7 newtons. So we don't need to take in consideration on the left hand side of this the mass of the particle A, or whatever it is, A. Then we set that equal to mass times acceleration. So now we use the mass, which is 2.5, and we set that equal to 2.5 times A. So acceleration we're going to find as part of what we need to do. Then we need to work out what's going on at B. So now at B. So this time tension is going away from the travel of direction. So that's going to be a minus T. Then we've got the mass B, so that's 1.5, multiplied by the force of gravity, which in this case is 9.81. So we've got plus 1.5 G, so the force of gravity, which we'll work out soon. And then 1.5 A is our mass times acceleration. Okay, so now we can calculate tension and acceleration from this by using a system of two equations with two unknowns, and we'll use simultaneous equation technique. So with T and minus T, it's always a good idea to add and get the T eliminated first of all. So then I've got minus 12.7 plus 1.5 G. So if I write that here, minus 12.7 plus, and what is G? G is 9.81. So plus 1.5 times 9.81 equals 2.5 plus 1.5, that's simply 4A. So now let's just simplify this off a little bit. So I've got minus 12.7 plus 1.5 times 9.81, that's going to give me 14.715, and that equals 4A. So now let's work this out. So 14.715 minus 12.7, that's going to give me 2.015. 2.015, and that equals 4A. So now to get A, just divide both sides by 4. So then A equals this divided by 4, which is going to give me just over 0.5. So I'm going to call it 0.5 meters per second squared. So that's our acceleration. So that equals 0.5 meters per second squared. So that's that taken care of. And then with that, we can now calculate what the tension is. So which one do we want to use? Doesn't matter which you use, it should give you the same result. So I'm going to just plug it into here. So now let's just draw a line under that. So I've got T minus 12.7 equals 2.5 times a half. Acceleration is a half. So 2.5 times 0.5. So then tension equals 12.7 plus 2.5 times a half. So that'll give me 1.25. So then tension is approximately 14.95. So let's write that down here. So that's approximately 14.95. That's allowing for our rounding error here for the acceleration there. So that takes care of that. Okay. So now what's left? Need to find the time taken for B to hit the ground. So Here we need one of our SUVAT equations. So let's write down which values we've got. So if I write our SUVAT variables here and then determine which ones we've got and which ones we need to find. So time taken to hit the ground, so we do need the t. We've got the v for velocity, so we do need to find velocity. Now s is our distance, which is 1 metre. Initial velocity, well, initial velocity would have been 0. And acceleration we're given as 0.5. So 0.5. So how can we calculate the time taken for it to hit the ground? Well, we can use one of the SUVAT equations, which is s equals ut plus 1/2 at squared. And then we can get our variable for t out of that when we solve for it. So s is 1, u is 0, so that all disappears. And then here we've got a 1/2 times acceleration, which is also a 1/2. So I'm going to write that as a 1/2 as well. And then t squared. So then this here is a quarter. 1/2 times a 1/2 is a quarter. So to get this t squared isolated, multiply both sides by 4. In which case t squared becomes 4. So t squared equals 4. In which case t would just be 2. So time taken to hit the ground would be 2 seconds. So that's quite nice there so far. Now we just need to find the velocity. So velocity, we can use our SUVAT equation again. So this is the one we need. This we've already found, which is 2. So now we can use v squared equals u squared plus 2as. So let's do that over here. So v is the velocity that we want, so stick with that there. Initial velocity is 0, so that disappears. So then we've got 2 times acceleration times displacement. So 2 times acceleration, I'm just going to put a 1/2 in, and displacement 1 metre. So I'll just put the 1 in, makes no difference of course. So then v squared equals 2 times 1 is 2 times a 1/2, gets me back to 1. So v is the square root of 1, which is just 1. So velocity on impact, 1 metre per second. Okay, and that will answer the 4 questions that we need. Okay.